Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, so for today, I will explain our last chapter for STA 210, which we call it as non-parametric methods. Okay, so previous topic, we already learned on hypothesis testing, but it was specifically for parametric method. Okay, so for this chapter, uh, again, this also is a hypothesis testing topic, but it focus on the non-parametric method. Okay, before we go further, I introduce first what is the non-parametric method. Okay, non-parametric method, also known as distribution-free methods, okay, used when the normality assumption cannot be fulfilled, and also other assumption that validate the use of parametric methods. Okay, if you still remember, for hypothesis testing of parametric method, there are several assumptions that need to be fulfilled. Okay, for example, we have assumption of normality, okay, equivariance, and so on. Okay, so that is the requirement for the parametric method. But for non-parametric method, okay, when the assumption that I have mentioned, which is regarding the normality and also the equivariant, cannot be fulfilled, then we have another choice or option to conduct the hypothesis testing by using the non-parametric method. Okay, for example, two judges rank 5 brands of detergent by assigning rank of 1 to the brand believed to have the best overall quality, a rank of 2 to the second best, and so forth. Finally, we want to see whether there is there any agreement between the two judges. Okay, so for example, I have judges A and judges B. Okay, we have 5 types of detergent, and I want to see whether these two judges have any differences into their preference to the detergent brand. Okay, so the use of rank here, okay, the use of rank will be applied on this method. Okay, kita banyak bermain dengan ranking, okay, for non-parametric method. Okay, so what are the condition for us for using the non-parametric method? Okay, non-parametric method can be used when the small sample size are involved in our experiment. Okay, unless the actual distribution is known exactly. Okay, but if you have the small sample size, but we sure what are the distribution of the sample that we have, then we can proceed with parametric method. Okay, but if we doesn't know what are the distribution, then we can choose the non-parametric method. Okay, secondly, the condition for using the non-parametric method is when the data are measured in categorical manner. Okay, for example, nominal or ordinal scale. Okay, the third condition, for the data in ordinal or interval scale, the distribution function is unspecified or other than the normal. Okay, but if you have ordinal or interval scale data, okay, we also can use the non-parametric method. Okay, but when the distribution not specified, meaning that distribution are not normally distributed, then we can diverge into the non-parametric method. Okay. But in terms of the powerfulness of the method between parametric and non-parametric, of course the parametric method still have the more powerful meaning lah. Okay, but if the condition of the data does not fulfill, then that's why we have another choice of parametric, a non-parametric method. Okay, so what are the advantages and the disadvantages of non-parametric method? Okay, in terms of the advantages, okay, it may be used on all type of data, okay, either categorical or ratio, and then it was easy to apply because it was involving the small sample size, and then the less assumption are needed in order for us to conducting the non-parametric method. Compared to parametric method, there are several assumptions that we need to fulfill before we conducting the hypothesis testing. Okay, in terms of the disadvantages, okay, the non-parametric method are less efficient compared to parametric method. Okay, meaning that if we have a data set, then the data set can be applied either parametric or non-parametric method. So it is better for us to choose parametric method, okay, compared to non-parametric method. Okay, when the sample size are large, the calculation become more tedious. Okay, so when we have a large data set, if we want to apply non-parametric method, the calculation will become more complex lah. Okay, and then the third one, in terms of the disadvantages, okay, the non-parametric method not utilize all the information in the sample. Why? Because we just use, most of the time we use the rank, okay, the ranking of the data set, not the value in terms of the mean or standard deviation. That's why it say that we are not utilizing all the information in the sample that we have, okay, because we are dealing with the ranking. Okay, note that if a parametric and a non-parametric test are both applicable, then we should carry out the more efficient parametric technique. Okay, as I mentioned just now, parametric method always more powerful than the non-parametric method. Okay, on certain situation, when some of the assumption cannot be met, such as the normality, then the non-parametric procedure much more efficient than the parametric method. Okay, but again, when the assumption for conducting the parametric method cannot be fulfilled, then we have a second choice, which we call it as non-parametric method. Okay, so from this table, I have summarized the test. Okay, I have made a comparison, the test statistic or a test that involve in parametric and non-parametric method. Okay, again, for non-parametric method, okay, we will dealing with single sample, dependent sample, independent sample, 3 or more independent sample. Okay, but for your cases, the third case, this one we will not cover in this topic. Okay, we just cover this 3 procedure. Okay, first one, okay, let's take a look into what are the tests that we will use when the data that involved are from the single sample or for one population. Okay, and under parametric method, we call it as one sample t-test. Okay, but under non-parametric, okay, the test that involve, it can be sign test, and the other one is sign rank test, or the other name for sign rank test is Wilcoxon sign rank. Okay, when the data that we have are from dependent sample or related sample or paired sample, okay, then the parametric test that involve are paired sample t test. Okay, but for the non-parametric method, we call it as sign rank test, or the other name is Wilcoxon sign rank test. Okay, and then the third procedure, okay, when we utilize data from the 2 independent sample, okay, to population that independent, okay, the parametric test, we call it as independent sample t-test. But for non-parametric method, the test that involve, we call it as Wilcoxon rank sum test, or another name is Mann-Whitney test. Okay. Okay, the last one. Okay, I'll just mention it. When we have three or more independent sample under parametric method, we will apply one-way ANOVA. But under non-parametric method, the test, we call it as Kruskal-Wallis ANOVA. Okay, so you need to understand these three tests. Okay, we need to focus on these three tests, and then I hope that you will be able to understand, okay, what are tests that involved when it was a parametric test and when it was non-parametric test for each procedure that I has list out here. Okay, so again we have single sample, dependent sample, and also independent sample. Okay, so for each this procedure, it has their own parametric and also non-parametric tests. Okay, now let's take a look into the first test. Okay, and for non-parametric method, which we call it as sign test. Okay, or the other name as binomial test when p equals to half. Okay, so this test is used to hypothesis on a population median. Okay, previously on the parametric method, most of the time you are dealing with either mean, standard deviation, or proportion, right? Okay, so for the non-parametric test, we are dealing with the population median. Okay, the assumption required here, okay, the sample involving should random, and then the measurement scale are at least ordinal type. Okay, so we have sign test for one sample or two related sample or two dependent sample. Okay, but for the sign test, we will focus only one sample. Okay, but I just write also for the two sample. Okay, again it still have left tail, right tail, and the two tail. Okay, for the null hypothesis, okay, for left tail, right tail, and the two tail, the null hypothesis will be written as tilde equals to tilde not. Okay, so yang ni dia punya sebutan dia. Okay, biasa kita guna X bar, betul tak? Okay, yang ni, this one we call it S bar. Okay, but for this one notation macam ni dia disebut tilde. Okay, tilde, tilde. Okay, ataupun dia adalah simbol untuk median. Okay, so we also can say that median equals to certain value lah, median not, ataupun tilde. Okay, dia punya simbol tu tilde. Okay, and then the H1 for the left tail, we have median less than on certain value. Okay, for the right tail, median greater than median not certain value lah, depends on the question. Okay, and then for the two tail, median not equal median not. Okay, this one is we have two sample. Okay, but we are not cover in this topic. We just focus only for one sample. Okay, and then the step 2 involving the test statistic. Okay, the test statistic here involving the binomial variable x with p equals to half. Okay, the probability of success only when p equals to half. Okay, so note that here p is the probability of having a positive sign. Okay, so x here for the left tail, x is the number of plus sign. For the right tail, x also is number of plus sign, and then for the two tail, x equals to number of plus or minus sign, whichever is smaller. Okay, nanti saya akan explain apa maksud plus and minus sign tu ya. let me explain first the procedure that involved under the sign test. Okay, and then you have to calculate the p-value for each tail lah, left tail, right tail, and the two tail. And for the left tail, the calculated p-value, okay, how to calculate the p-value is the probability value for x less than or equals to x when p equals to half. Okay, so you have to familiar or memorize with the symbol. Okay, nanti dia akan menyebabkan kita akan tengok table binomial ya. Okay, and then for the right tail, the probability value is calculated when for probability of x greater or equals x when p equals to half. Okay, yang ni sign dia probability of x greater or equals x. Okay, and then for the two tail, okay, we will consider two condition. Okay, first, if x, which is our number plus sign or minus sign, okay, if x less than n over 2, then the calculated p-value is equivalent to 2 times probability of x less than or equals x when p equals to half. Okay, but if you check x, which is number of plus or minus sign ni, kalau x dia greater n minus 2, then the probability value is 2 times probability of x greater or equals x when p equals to half. Okay, and then the critical value for left tail, right tail, and the two tail, we just compare with alpha for ketiga-tiga condition lah. Okay, maksudnya we will reject the null hypothesis if p-value less than or equals to alpha. Okay, and then the last one, we have to make a decision and also the conclusion. Okay, I just want to recap back what you have learned on STA 150 for the binomial distribution. Okay, if you still remember, binomial distribution, we have two parameter. Okay, it can be written as x has binomial distribution with parameter n and p. Okay, so n is the number sample size, p is the probability of success. Okay, and then if we want to find the probability of x equals to x, if you still remember, the formula is given by n cx p to the power of x q to the power of n minus x. Okay, where q is 1 minus p. Okay, so I hope that you still remember how to calculate the binomial probability. Okay, so I just recap back. To find the probability of x equals to x, we should use formula n cx p to the power of x q n minus x. Okay, don't worry. I know that you still cannot see what are actually sign tests. Then after we look for the example, I hope that you will understand. Okay, let's take a look into example 1. The following data represent the number of hours that a rechargeable H trimmer operates before a recharge is required. Okay, use the sign test to test the hypothesis at the 5% level of significance that this particular trimmer operate a median of 1.8 hours before requiring a recharge. Okay. Okay, so how to do this? Okay, so look at the sample size that we have. Okay, so we have 1.5, 2.2, 0.9, and up to 1.7. Okay, so what we want to test? We want to test whether the median is equivalent to 1.8 or not. Okay, so that will be our H0 and also the H1. Okay, so the null hypothesis and the alternative hypothesis here, median equals to 1.8 or median not equal 1.8. Okay, this one is two-tailed. Okay, before we proceed to the second step, we calculate the test statistic, what should we do here? Okay, we need to replacing each value by the symbol plus if it exceed 1.8. Okay, so our test value here is 1.8. Kalau data kita greater than 1.8, then we should replace by plus symbol. Okay, if your value is less than 1.8, we will replace with the symbol minus. Okay, then now we will look one by one. Okay, so 1.5 is less than 1.8, so meaning that we should put a negative sign here. Okay, minus sign. 2.2 is more than 1.8, so this one is plus. This one is minus, plus, minus. Okay, so if your data set are equivalent with the test value, which is 1.8, then we will exclude this observation from our calculation. Okay, so meaning that our n will be reduced lah kalau ada data yang sama dengan the test value. So since our test value here is 1.8, so kalau ada data yang sama, bermaksud dia akan di-exclude lah daripada computation. Okay, for 1.5 it was less than 1.8, meaning that we have to put negative sign. This one is positive, negative, and also negative. So again, saya repeat back. Okay, kalau data kita tu lebih daripada test value yang kita nak test, untuk case ni adalah 1.8, kalau lebih awak kena letak positive sign. Kalau dia kurang daripada value yang kita nak test, kita akan letak negative sign. Senang cerita, maksudnya kita tolakkan data kita tu, kita tolakkan dengan value yang kita nak test. Kita akan dapat negative value kan. 1.5 tolak 1.8, kita akan dapat negative. And then 2.2 tolak 1.8, kita akan dapat positif kan. Tapi kita just nak ambil dia punya sign sahaja. Again, kalau ada data set yang sama dengan value yang kita nak test, maksudnya kalau kita tolak, kita akan dapat kosong kan. So it will be excluded from the computation. Maksudnya n kita nanti akan berkurang lah. Okay. Okay, number 2. Now kita nak calculate dia punya test statistik. Okay, so kalau kita tengok kat sini, n kita dah jadi 10 10, and then sekarang ni kita ada, kalau kita tengok kat sini, kita punya positive sign dengan negative sign. Positive sign kita ada 1, 2, 3. Okay, positive sign we have 3. Negative sign we have here 1, 2, 3, 4, 5, 6, 7. Okay, so we have 7 negative sign here. Okay, if you look back at the procedure that I have summarized at previous page. Okay, kalau kita punya H1 kita adalah this one, unequal, so kita akan observe positive or negative sign, which yang mana yang lagi small. Okay, so kalau kita tengok kat sini, antara 3 dan 7, yang lagi smaller adalah 3, which is referring to the plus sign. So our x here, okay, so our x here adalah x here is our positive sign, which is equivalent to 3. Sebab kalau unequal, kita akan tengok mana yang lagi rendah value dia. Sama ada value plus or value minus. So kat sini contohnya yang paling rendah adalah referring to the plus sign, which is equivalent to 3. So kita akan ambil value 3 itulah. Okay. Kalau contohnya kalau dalam example tu yang paling sikit adalah referring to the negative sign. So kita akan ambil value berapa value negative sign tu. Okay. Yang rendah tu lah. Okay. So we can write here as X has binomial distribution with n equals to 10 and P equals to half. Kita fix ya, P kita adalah half, Y half. Okay, kalau perasan median tu kan berada di tengah-tengah. Okay, so sama ada dia akan membahagikan kepada dua distribution lah. Sama ada dia berada di tengah-tengah. Dia membahagikan kepada dua distribution tu ya. Okay, so set yang ketiga, kita nak calculate dia punya P value. Okay, so untuk this kind of symbol, okay, unequal, kita ada dua tadi kan. Kita nak tengok okay, kita nak tengok pula condition. Okay, adakah X kita tu kurang N over 2 ataupun X kita tu greater than N over 2. Okay, X tadi kita dah decide adalah simbol yang mana lagi smaller. Okay, so kat sini kita decide kita punya the smaller sign is referring to the plus sign, which is 3. Okay, so N kita 10. Kita dah tahu N kita 10. So kita check. Okay, kita check X kita tadi 3 kan. 3 adakah dia kurang atau lebih besar N over 2. Okay, 10 bahagi 2 adalah 5. So 3 adalah kurang daripada 5 kan. So the P value here will be, so the P value kita akan tulis sebagai 2 times probability of X kurang sama dengan X. Okay. So how to get the value of the probability? Kita akan refer table binomial. Okay, so ni saya tulis balik 2 times P probability of X kurang sama dengan 3. Kenapa 3? Tadi kita dah decide kat sini. Kita akan refer the positive sign because it has the smaller value. When we count the value of plus and minus, the smaller one is referring to the plus sign. So kita akan tulis 2 times probability of X kurang sama dengan 3. Okay. Okay, if you still remember, in order for us to use the cumulative binomial probability, kita kena convert semua sign tu kepada kita kena convert dia menjadi kepada X greater or equals to R. Okay, so in order for us to convert this sign, okay, so dia akan jadi 2 times P kat sini ya, probability of X less than or equals to 3, it also equivalent to 1 minus probability of X greater or equals to 4. Maksudnya kita kena convert semua sign tu kepada greater or equal. Okay, kalau awak tengok garis nombor, okay, kat sini 0, 1, 2, 3. Kita nak probability of X kat sini kan kurang sama dengan 3. Okay, tapi apa yang perlu kita buat? Kita kena buat 1 tolak probability of X greater or equal to 4. Baru kita dapat yang belakang ni. Okay, yang kat sini. Sebab apa? Sebab dekat table ni dia hanya bagi probability of X greater or equal R. Okay, so kita akan convert probability of X less than or equals to 3 menjadi 1 tolak probability of X greater or equals to 4. Okay, now kita akan tengok kita punya binomial table ni. Okay, awak cari dekat N equals to 10. Okay, so here lah N kita 10. Okay. N kita 10, we just fokus kat N 10. Okay. R kita adalah, tadi kita nak cari satu tolak probability of X greater or equals to 4. So meaning that kat sinilah R kita 4. Okay, and P kita adalah 0.5. Kita hanya fokus dekat 0.5 sahaja ya. Okay, so probability of X greater or equals to 4 is 0.8281. Okay, so meaning that probability kat sini tadi kita dah tukar. This one menjadi 1 minus probability of X greater or equals to 4. Okay, so from the table we get the value is, this one is 1 minus probability of X greater or equals to 4 is 0.8281, which is equivalent to 0.1719. Okay, so kita akan darabkan 2 darab dengan probability of 1 minus probability of X greater or equals to 4, which is equivalent to 2 times 0.1719. So this one we will get 0.3438. Okay, now we proceed to next step. Reject hash not if P value less than or equal alpha, right? Okay, so since P value kita adalah 0.3438 is greater than alpha 0.05, then we fail to reject the null hypothesis. Fail to reject the null hypothesis. Okay, so when we fail to reject the null hypothesis, meaning that the median are equivalent to 1.8. Okay, so this one is the solution for example 1. Okay, now let's take a look into example 2. The following sample of 6 data, the length of a particular plant in millimeter were recorded from an experiment. So we have 1, 2, 3, 4, 5, 6 observation here. So at 5% significant level, use a sign test to investigate whether the median length of the population of plant is greater than, okay, greater than 1.5 mm. Okay, now we already identify what are the hash knot and h1 here, so we can write the hash knot here as median equals to 1.5, h1 median is greater than 1.5, so this one is right tail test. Okay, so now we should identify the symbol or the sign here, either plus or minus. Okay, then we will compare with our hypothesis value. So our hypothesis value here is 1.5. So data kita bila kita tolakkan dengan hypothesis value kita tengok dapat positive sign ke negative sign. Okay, so untuk for this one 1.0 minus 1.5 kita akan dapat negative sign. Okay, so this one kita akan exclude from the computation because it was equivalent to the hypothesis value. Okay, for 1.8 minus 1.5 we will get positive value, this one positive value, this one negative value. So meaning that our minus sign we have 2, plus sign we have 3. Okay, so if you look back at the table of procedure that I have summarized, okay, when we have this one, when we have greater sign here, so what we will observe is the plus symbol. Okay, so plus symbol here, we have 3. So meaning that X, we have 3 here, number of plus sign, and N, we have 5. Okay. So it can be written as X has binomial distribution with N equals to 5, P equals to half. Okay, again, the P here is fixed, half. Okay, so what should you do? We have to find the probability value of X greater or equal 3. Okay, so this value can be obtained from the from the table. Okay, what should you observe? You should observe at the N equals to 5. Sorry, salah lagi. N equals to 5 here, this one. Okay, N equals to 5, and at P equals to 0.5. Okay, now we want to find probability of X greater or equals to 3. So awak cari R kat sini 3. So maksudnya value dia adalah 0.5. Okay, so probability of X greater or equals to 3 is equivalent to 0.5. Okay, so kita dah dapat value dia. Probability of X greater or equals to 3 is equivalent to 0.5. So meaning that our P value adalah, okay, step yang kedua, test statistik kita adalah in term of P value lah. So P value is equivalent to 0.5. Okay, alpha kita adalah 0.05. Okay, we will reject hash not if P value less than or equals to alpha, right? Okay, so since we get P value 0.5, alpha kita 0.05. Okay, so since 0.5 is greater than 0.05, then we fail to reject hash not. When we fail to reject hash not, meaning that our median is equivalent to 1.5. Okay. So always be careful here. Okay, at this part. Okay, if probability kat sini memang clear lah, sebab kita right tail, so kita akan cari probability of X greater or equal kan. Kalau kat sini katakan left tail, kat sini dia akan menjadi probability of X less than or equals to 3. So contoh, kalau saya bagi contoh kalau dia adalah left tail, okay, sign H1 awak adalah median less than. Less than So kalau less than, kita akan tengok probability of X kurang sama dengan 3 kan. So awak kena convert yang ni. Probability of X less than or equals to 3 adalah sama dengan 1 tolak probability of X greater or equals to 4. So awak carilah probability of X greater or equal 4 adalah sama dengan, ni contoh je lah, saya bagi contoh N kita 5 tadi kan. N kita 5. N kita 5. Okay, awak cari probability of X greater or equals to 4 for P kita 0.5. So dia adalah bersamaan 1 tolak 0.1875. So awak tolakkan dulu 1 tolak 1875. So dapatlah dia punya probability value. Okay, so always remember, value yang dekat dalam table ni, dia hanya bagi probability of X greater or equal. So kalau kita nak probability of X less than or equal certain value, so awak kena convert dia menjadi probability of X greater or equal. Okay. Okay, now let's take a look into example 3. To check the claim that drinking coffee affects the pulse rate, the change in pulse rate was recorded for 10 subjects after all of them drank 1 cup of coffee. Okay, so these are the pulse rate there. Okay, use an appropriate test to test the hypothesis that the median change impulse rate is greater than 5. Use alpha equals to 0.05. Okay, so kat sini dia tak kata appropriate test. Okay, tapi kita tahu dah data kita hanya ada satu group sahaja. Kita bukannya comparing between two groups. Okay, so the suitable or the appropriate test here adalah sign test. Okay, so kita daripada sini kita dah identify what are the H0, H1. So dia nak test median pulse rate is greater than 5. Okay, so we can write the H0, H1 as median equals to 5, median greater than 5. Okay, so now we have to find out first the number of plus sign and minus sign. Okay, so kita tengok data yang pertama. Data yang pertama kita 4. Kita compare dengan kita punya hypothesis value kita 5. So kita akan dapat negative sign. This one also negative, negative, positif, positif, positif. Kenapa positif? Sebab dia lebih daripada 5 kan. Kalau kita tolakkan data ni dengan 5, kita akan dapat positif. Yang ni kenapa negatif? Sebab kalau kita tolakkan data ni dengan 5, kita akan dapat negatif. Itulah maksud dia. Okay, so this one kosong tolak 5, kita akan dapat negatif. 10 tolak 5 positif, positif. 6 tolak 5 kita akan dapat positif. Okay, so kat sini positive sign kita dapat. Kita ada 1, 2, 3, 4, 5, 6. Minus sign kita dapat 1, 2, 3, 4. Okay, minus sign kita dapat 4. Okay, tapi kita tengok balik. Since we are dealing with H1 kita mu greater than 5, so apa yang kita nak observe adalah we should focus on plus sign lah. Okay, so our plus sign is greater than equals to 6. So meaning that X kita adalah plus sign kita 6. And kita ada 2, 4, 6, 10. And kita ada 10. So meaning that it can be written as X has binomial distribution when with n equals to 10, P equals to half ataupun 0.5. Sorry. P kita equals to half or 0.5. So now we have to find the probability value. Okay, so dia punya P value kita adalah probability of X greater or equals to 6. Okay, so yang ni kita boleh terus dapat daripada table. Okay, tengok N kita 10. N kita 10. Okay, P kita 0.5. Kita nak probability of X greater or equals to 6. So tengok kat sini lah. Cari R dia 6. So the value is 0.3770. 0.377. Terus ambil straight away sebab kita punya this one notation kita adalah probability of X greater or equals to 6. Kalau dia kurang, contoh probability of X less than or equals to 6, awak kena convert dia menjadi 1 minus probability of X greater or equal 7. Ni contoh sahajalah, tapi untuk this case dia memang probability of X greater or equals to 6. So kita akan straight away dapat daripada table. Okay, now the third kita dah ada P value. This one is second step. Okay, the third step alpha kita adalah 0.05. So kita punya rules kita reject H0 if P value less than or equal alpha. Okay, so since 0.377 is greater than 0.05, then we fail to reject hash knot. So when we fail to reject hash knot, meaning that median equals to 5. Okay, median change in pulse rate is not greater than 5. It was equivalent to 5. Okay.